Hey everyone, welcome to section P3, which is talking about functions and their graphs. Graphing is going to be a huge part. Sometimes you're going to be able to use your calculator. Sometimes they're not going to allow you to do that. So you're going to have to know kind of what some sketching is going to look like. It doesn't have to be super accurate. They're not going to be worried about that, but they are going to be thinking that you should know what a cubic function looks like, or function notation, or all that stuff that sometimes we do with graphs and sometimes we don't. So let's focus on functions first. Functions, as you remember from Algebra 1, and then we saw it in Algebra 2, and then again in trig, is one input has one output. Alright, it's that simple. But now we're going to be looking at domain. Domain and range is going to become more important in calculus because sometimes your functions are not going to be defined at certain values for x. So you have to kind of say, well, this function works for everything except for x equals 2. Or domain is only for x is between 4 and 5. Or something like that. And then the range is kind of the same thing. It's all the possible output values. So these are going to become more into play this year. It's just going to take some practice, and you'll get better at it. Next, we're going to talk about, there are several forms that we can talk about: implicit, explicit, and then also function notation. Implicit form is when x and y are on the same side, right? So we got x squared plus y squared equals 1. Then the same side of the equal sign. That's called implicit form. Explicit form is like when you solve for y. So like y equals 3x minus 7. That's explicit form, meaning to be solved for a variable. Explicit form and function notation are kind of the same thing. Alright? So that way, we can also write function notation in several ways. We've seen f of x, g of x, h of x. We're also going to be using other variables. Sometimes s works, sometimes t works, depending on the real-world situation that we're dealing with. So if we're talking about time or seconds or feet or height or whatever, you might see a different variable. Don't freak out. It's just whatever variable is inside, that's going to be the variable. Right, so you've seen f of x, so f of s, s squared minus 3s. G of t, t to the third plus cosine t. Alright, just tells you which variable you're going to be using. Okay, good. Now let's do a couple examples here. Let's look at example 1. This is kind of an important one, especially when you get down to C. If you're given f of x equals x squared plus 7, we're going to evaluate f of 3a. We're going to evaluate f of b minus 1, and f of x plus delta x minus f of x all over delta x when delta x is not equal to 0. This is one of those things when we're talking about domain. We have to say that delta x does not equal 0, because if it equals 0, then this whole thing is going to be divided by 0, and then we'll get an error. So that's the only time we can't have delta x be defined. So we have to say that it does not equal 0, so that way we don't have this whole thing fall apart. Okay, so all we're really going to do is take that 3a, and we're going to put it in for that x squared, right? So you'd say that f of 3a is going to equal 3a squared plus 7. All right, we're not going to quite leave it like that. We're going to leave it as 3 squared is 9a squared plus 7, and that would be our answer. All right, next we're going to do b, so that's going to be b minus 1. So we're going to say f of b minus 1 is going to equal, we're going to place x squared with the b minus 1. So we're going to say b minus 1 squared plus 7. And we're not going to leave it like that. So what we're going to do is you can use the FOIL method. Otherwise, if you kind of remember some shortcuts, that's okay too. That was going to be b squared minus 2b plus 1 plus 7. And we're going to combine our like terms to say that's b squared minus 2b plus 8. If you want to go and check the FOIL method, you can, but that is what it's going to look like. All right, next, C. This whole thing is called the difference quotient, and it's going to be important in our next section for limits. So this is going to be something you're going to see a lot more, so I thought, why don't we just try this one, given some function notation, so you get used to what this exactly is going to look like. All right, so what we're going to do is we're going to place x with x plus delta x. All right, so we can say that f of x plus delta x, that's going to be the same as, we're going to put in parentheses, x plus delta x squared plus 7, right? The only thing we did was replace that first value with the stuff that's inside the parentheses here. Okay, so we have that. So then we can say this whole thing is going to be x plus delta x squared plus 7. And then we're going to do minus our original f of x, which we don't have to change anything. It's still going to be our same function, x squared plus 7. And that's going to all be over delta x. So the only thing that really changed from our original problem to here, what we did was we replaced the first part, x plus delta x, with this, replaced f of x with this, and kept the bottom the same. Alright, so now let's FOIL this, right? So we get x squared plus 2x delta x plus delta x squared plus 7 minus x squared plus 7. Oops, and let's put this whole thing in parentheses. I should do that because we're going to distribute that minus. And it's going to be all over delta x. Alright, now can we combine anything? Well, first let's distribute this minus to both of them, and this x squared and this x squared cancel out. This 7 and this 7 cancel out. And we're left with 2x delta x plus delta x squared all over delta x. Alright, and what do they both have in common? They both have a delta x in common on the top, so we can say that's going to be delta x, parentheses, 2x plus delta x all over delta x, and those will cancel out, so we'd be left with 2x plus delta x. Alright, and remember, the only thing we can set, we also are going to say this just for the domain, is that delta x cannot equal 0. So we're going to include that in there. And why can't delta x equal 0 even though we're not dividing anymore? Because before we simplified it, we were dividing by delta x, and we don't want that to equal 0. Alright, so there is example number 1. Let's do example number 2. And that says, find the domain of the following functions. So we're going to say f of x equals 1 over x squared minus 4 for x is between 4 and 5. Alright, so what we're going to do is let's just make sure that it works for this part right here. So let's go over to our graphing calculator. We'll put that over here. And I've already put them in to save us some time here. So number 1, if I graph this, let's see what happens. And there it is. Alright, so let's just check to make sure that at between 4 and 5, it works out. I go to the table, and let's go to 4 and 5. It goes between here and here, and it looks as though it's going to be okay for that interval. So let's just check the table or the graph one more time. Between 1, 2, 3, 4, 5, it looks as though it's going to be okay. So our domain is going to be between 4 and 5. So how do you write that? We can say that our domain, we can say it this way. We can say there, x. So that way we know it's x value in case the domain is not the necessarily x. It might be y, it might be z, it might be whatever. And we're going to say that is 4 less than or equal to x less than or equal to 5. Oh, and I kind of messed that one up. That's okay. Alright, so now let's do it. What happens if we don't have this restriction? What happens if it's just 1 over x squared minus 4? Well, remember that domain is as long as the whole thing doesn't fall apart, divide by 0 error, for those of you using your calculator, that's what we're really trying to avoid. So, is there a time when x squared minus 4 is going to equal 0? And if there is, that's when we're going to say that we can't have x equal that thing because it's going to divide by 0, and then we'll have a problem. So, is there a number that when you square it, minus 4 equals 0? Yes, I'm sure that a lot of you said 2 is one of them. Is that the only answer? And if we go back to our graph real quick, let's just look here. There's x equals 2 is 1, but it looks like there's another one over here. Oh, that's right. It's the negative 2. Don't forget the x equals negative 2 as well. So if we have those two things, those are bad. Frowny face. Alright, so what we're going to say is that for the domain, we're going to say for domain x, we can say that x cannot equal plus or minus 2. Alright, can't equal plus or minus 2. Now you could say it could equal everything but plus or minus 2. That takes a long time. So instead, why don't we just say it excludes those two. Alright, so now let's look at the last one. We're looking only at domain. H of x equals 1 minus x if x is less than 1, and the square root of x minus 1 if x is greater than 1. So it's something called a piecewise function. So what we're going to do is we are going to look at that, and I couldn't quite get it on my graphing calculator to do it all at one time, so what I ended up doing was I just plotted it as two separate ones. Alright, so if you see, I'm just going to turn these on here real quick, and you see I wrote x, or 1 minus x, for x is less than 1, and the square root of x minus 1 for x is greater than or equal to 1. So if we go to graph this function, there's the first part, and it has this, well, there we go. And it has this extra black line and extra red line. I'm not exactly sure why they're there, and I couldn't get rid of them. And when I try to graph it all at once, it gave me a problem anyway. So we're just going to say we're not going to think about this black part over on the left side or this red part on the right side. Okay, so as we go this way, it looks as though between negative 10 and 10 for x, we don't have any problems, right? So if I go back and I just look at this, is there anything that x can't equal so that turns to divide by 0? No. If I have this one, is there anything that it's not going to work out for? Well, if the square root of a negative, that would be a problem, right? But the smallest I can get to is x is greater than or equal to 1, so that's the smallest one. So if I take the square root of 1 minus 1, I get the square root of 0, which is still going to be 0. So that's okay. If x was anything less than 1, then we'd have a problem and we'd have to make those restrictions. But we don't have any, so for x, and let's put the brackets, we can say that between negative infinity is less than x is less than positive infinity. Alright, so we have all possible values for x and y. Alright, there you go. I know it's kind of long, but there is your first one for this section.